Hi everyone, welcome back to our channel. Let's try to find out the solution for this problem. Problem number 15 is the following measurements are obtained on an two-terminal network when a voltage of 100 volts is obtained at the input port with output port is open. So here what is mentioning is output port is open, which means that I2 is equal to 0. Then input current and output voltage is given. So again, when a voltage of same 100 volts is applied at the output port, okay, then with input port is open. Input port is open means I1 is equal to 0. So when a voltage of 100 volts is applied at input, what is this value? V1 value. When a voltage of V is applied at the output port, what is this value? V2 value. So I2 and V1 are given. He is asking us to find out the diagonal parameters, which are nothing but input driving point impedance, and this is a transfer impedance, this is reverse transfer impedance. So we need to find out. How to find out is, so we know the basic equations of V1. So the solution for this is V1 V2 is equal to Z11 Z12 Z21 as well as Z22 into I1 I2. So from here what we can do here is, so from this equation we'll try to write down the equations of V1 and V2. Okay, so here V1 is equal to Z11 I1 plus Z12 I2 is one equation. Second equation is V2 is equal to Z21 I1 plus Z22 I2. So here we are going to make, as per the given problem, output port is open circuited. Okay, so whenever I2 is 0, okay, so I2 is 0. Whenever I2 is 0, then automatically Z11 is equal to V1 by I1. So I2 is 0, Z21 is equal to V2 by I1. And so these values are, you can see here. So a voltage of is applied at input port. Input means V1 is applied. What is the V1? So V1 given is 100 at an angle 0 divided by, so 100 at an angle divided by, what is the current given? 20 at an angle 0. So 20 at an angle 0. So next one, for the same port we require V2. V2 given is as 25 at an angle 0 divided by I1. I1 is 20 at an angle 0 degrees. This is what given. Second bit given is when a voltage of 100 is applied when input port is open circuited. So whenever input is 0, I1 is 0, I2 is 0. Therefore, we are going to find out. So this I1 is 0. Therefore, Z12 is equal to V1 by I2, and Z22. Z22 is equal to V2 by I2. So here what we require is V1 by I2. What is the V1 value given to the problem? 15 at an angle 0, 50 at an angle 0. I2 given is 10 at an angle 0. And what is the V2 given in the problem? 100 at an angle 0 divided by I2. I2 is 10 at an angle 0. So if you don't know this, how to express in R comma theta, you can refer our old videos, how to solve complex numbers, a video on how to handle complex number addition, subtraction, division. Okay, so then you will get a clarity here. So this directly we can divide. So this is nothing but 5 at an angle 0 ohms. This is 5 ones are 5. So 5 at an angle 0. This is 25 divided by 25 divided by 20, which is 1.25 ohm. Next one is 10 ohms. So these are the values what we are going to get. So by solving this, so this is the resultant self. This is called input driving point impedance. This is called output driving point impedance. This is called transfer impedance. This is called reverse transfer impedance. The ultimate units are nothing but ohms. This is how to solve this problem and how to obtain the Z parameter when a question is asked in this domain. So hope you are able to understand. We'll meet in the next video. Thank you for watching. So if you substitute this in the equations also, the equations we will be getting it as V1 is equal to Z11. What is the value of Z11? So 5 at an angle 0 I1 plus Z12. Z12 is 5 at an angle 0 I2 is one equation. Second equation is V2 is equal to Z21 1.25 I1 plus 10 into I2. So this will be the corresponding voltage equations if you want to represent. Hope you're able to understand the problem. If you feel the video is useful to you, please give a like and please share with your friends. And if you have any doubts, let me know in comment section. And if you're watching for the first time, subscribe to the channel with the name KV Tulasiram. So this is a free channel for the betterment of students, those who are preparing for exam. So if you have any doubts, let me know in comment section. I will answer. Yours obediently Ram. We'll meet in the next video. Thank you for watching.